Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine an equation of the tangent at the given x coordinate. So let's start with the first function, f at x equals cos of 2x plus pi over 3. So we have to find the equation of the tangent to this function at x equals pi over 4. So we know that tangent is a straight line and the general equation of a straight line is y equals mx plus b. So we have to find the slope, which is the m value, and the y-intercept, which is the b. So we should start with the slope. So the slope of the tangent is equal to the first derivative of the function at x equals pi over 4. So we have to find the derivative of this cos function, and for that we have to use the chain rule because this cos term has an outer function which is the cos function and the inner function is the polynomial function 2x plus pi over 3. So as per the chain rule, we start with the derivative of the outer function and the derivative of cos is minus sign. Times the derivative of the inner function, and the derivative of 2x is 2 times 1 plus 0 because pi over 3 is a constant. So for 2x, the derivative is 2 times 1 because 2 is the coefficient, so it stays as it is, and the derivative of x is 1. Now we can simplify this expression. So in the second parentheses, 2 times 1 is 2 and 2 plus 0 is just 2, and we can multiply 2 by this sign term. So we get now we can sub in x as pi over 4 in this expression for slope. Now 2 times pi over 4 can be reduced to just pi over 2 because the 2 and the 4 can be reduced. Now we can find the value of this sine term by using the sine angle sum identity. So if you remember, the identity is, so I'll write it on the board, sine of a plus b so this is the identity we have to use. So in our expression a is pi over 2 and b is pi over 3. So we get so this is the expanded expression, and now we can sub in the values for the sine and cos terms. So we know sine pi over 2 is equal to 1 and cos of pi over 3 is equal to 1 over 2. Cos of pi over 2 is 0 and sine pi over 3 is square root of 3 over 2. Now we can simplify this expression. So 1 times half is just half, and then 0 times square root of 3 over 2 is 0. So we get m equals negative 2 times half, which is equal to just negative 1. So this is the slope of the tangent. So now we can sub in this m value in the general equation. Now negative 1x can be written as just negative x. Now we have to find the b value. So for that we need to know a point that lies on this tangent. And we can find that point from the given function and the x coordinate. So we should sub in this x value in the given function to find the y value for that x coordinate. So now 2 times pi over 4 can be reduced to just pi over 2. So the 2 and the 4 can be reduced. So we get now we have to use the cosine angle sum identity. And the identity for cosine is so this is the identity we'll use. Now in our expression a is pi over 2 and b is pi over 3. So we get now we can evaluate these sine and cos terms. So cos pi over 2 is equal to 0 and cos pi over 3 is 1 over 2 minus sine pi over 2 is 1 and sine pi over 3 is square root of 3 over 2. So 0 times half is just 0, so this term will go away. So we are left with just negative square root of 3 over 2. So the point that lies on the function and on the tangent is so we can sub in this point as x and y in this equation of the tangent to find the value of b. So we sub in y as negative square root of 3 over 2 and x as pi over 4. So we can move this negative pi over 4 to the left side and it will become a positive term. So this is the b value for the tangent. So the equation of the tangent is, so this is the equation of the tangent in slope-intercept form. Now we can analyze the second function. Now the second function is f at x equals 2 sine x cos x, and x is equal to pi over 2. Now the first thing we should do is modify this given function and reduce it using the double angle identity for sine. So we know that for sine, double angle identity, sine 2x is equal to sine x cos x. So we can rewrite our function as, so this is the first step. Now we have to find the equation of the tangent, and the general equation is, and we can start by finding the slope of the tangent, which is equal to the derivative of the function at x equals pi over 2. Now for sine 2x, we have to use chain rule because the outer function is sine and the inner function is the polynomial function 2x. So we start with the derivative of the outer function, and the derivative of sine is cos, times the derivative of the inner function, and the derivative of 2x is 2 times 1. So now we can simplify this expression. So 2 times 1 is 2, then we can move the 2 to the front. Now we can sub in x as pi over 2 to find the slope of the tangent. So in the cos term, the 2's get cancelled out. And cos pi is equal to -1. So the slope is equal to -2. So now we can sub in the slope value in the equation. Now we have to find the b value. So for that we need to find a point that lies on the tangent, and we can get that point from the function. So we'll sub in x as pi over 2 in the given function. So we can use the modified function expression. So the 2's get cancelled out. So we are left with sine pi. And we know that sine of pi is equal to 0. So the point is, so we can sub in this point in the equation of the tangent to find the b value. So we'll sub in y as 0 and x as pi over 2. So the 2's get cancelled out. Now we can move this pi term to the left side, and that will make the pi term positive. So this is the b value for the tangent, and now we can write the equation of the tangent. So this should be the equation of the tangent in slope-intercept form. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.